All right, guys, so this is called a literal equation, okay? So basically it is like a regular two-step equation or any other equation, honestly, where we're solving for a single variable. For instance, I'm just gonna give you something real basic real quick, okay? If we have something like 10 equals x plus 3. If we want to solve for x, we've got to get rid of this 3. So the only way to get rid of adding 3 is to subtract 3. And if I subtract 3 from one side, in order to keep this an equal statement, I have to subtract 3 from the other side. Okay? Because right now, both sides equal 10. So if I subtract 3 from one side, I've got to subtract it from the other side. Okay, now I know most of you didn't need to do that in order to solve and find out that x was 7. But we still have to know this skill in order to work more complicated problems. Okay, so here's a problem above here. It says a plus b equals c. Now we know that all these letters represent numbers, okay? But we know they're different numbers because it's a, b, and c. If they were the same numbers, they would use the same letter. Okay, so in this problem, I don't want to know what a equals. I actually want to know what b equals. All right, so what I have to do, if I want to know what b equals, that means I've got to get b by itself. So what you look for is okay, what is there over here with b, okay? Now I have two sides to an equation, right? Now I have a over here, and then I have b plus c. Okay, so I want to get this b by itself. Okay, so that means the only thing I've got to get rid of is this c. Now here's the thing. You want to do what you have to get rid of that number entirely. Okay, so if you think about it, if I were to add c, the opposite of that would be to subtract c. So if we know they're the same number, so if I had 5 and I subtracted 5, it would be gone. Okay, so most of the time, if you are adding something, the way you're going to get rid of it is subtracting it. So if I am going to subtract c, I'm now taking c away from this side. So in order to keep this an equal statement, I've got to subtract it from both sides. Okay. So now I have a minus c. They're not the same letter, which means I can't combine them. So this just becomes a minus c. I'm going to rewrite that. A minus c equals, bring it down. B, I didn't do anything to, so I'm going to bring it down. And I told you I'd added c, and then I subtracted c. So that basically cancels out, and it's gone. Now, as you notice, I said I want to solve for b. I said I want to know what b equals. Well, now it reads a minus c equals b. So b equals a minus c. Okay. So let me do a couple of the other basic ones. Okay, I like using the same numbers just because, or the same letters just because it makes it easier for me. A equals b minus c. All right. So in this case, again, if I were to solve for b, I've got to get rid of minus c. Well, in order to get rid of minus c, I would add c. If I add c to one side, I've got to add it to the other. Okay, now it says a plus c. Since they're not the same letter, I can't combine them. So I rewrite it a plus c equals, bring b down because I didn't do anything to it, and if you had minus c and then you added c again, you've gotten rid of it. So I have solved for b here. Right. Now we're going to write a equals b, c. And when you have two letters next to each other, or a number next to a letter, that means multiplication, even though there's no multiplication sign here. So I know that these two are being connected through multiplication. All right? So the way that we undo multiplication is division. Okay? I'll give you a quick example of that. If I took 6, I started there and I said, hey, I'm going to multiply by 2. And then I'm going to divide by 2. That would give me 6. So taking 6, multiplying by 2, and then dividing by that same number puts me back where I started. So as long as you're using the same number, if you use the opposite operation, so multiplication and division, addition and subtraction, it's going to cancel out. So here I'm going to, again, I'm going to solve for b. So I want to get b by itself. Well, in order to undo multiplying by c, I need to divide by c. So I'm going to use a fraction bar to show division. So if I divide this side by c, in order to keep things equal, I've got to divide this side by c. All right, so a divided by c we can't do because they're not the same letters. So I just have to rewrite it. And then here we have bc divided by c. Well, if you look at this, it says c basically divided by c. We know that's the same number. So think about regular numbers. If I said 5 divided by 5, that's 1. So this is the same number being divided by itself, 1. So we're left with 1b. And I said a number next to a variable means multiplication. So 1 times b is just b. So in a sense, you have canceled out that c by dividing it. And now we know that a divided by c equals b. All right, one more really basic one. So now we have a equals b over c. All right, and if I want to solve for b this time, our c is being divided. So we're going to do the opposite of dividing by c, and we're going to multiply by c. And I'm probably not going to use an x there. I don't want to confuse it with an actual x. So I'm going to write in parentheses a c, and I'm going to write a parentheses c down here, because that also means multiplication. So I'm going to a times c. Again, not the same letter, so they can't be combined. So this becomes ac. And then, like I said earlier, if you divide by a number and then multiply by that same number, it's as if it never happened. So you're left with b over 1, which is just b. So a c equals b. Okay, so this is all the same process of doing, like all the same, I'm using the same letters, but it's different. These are all different problems, okay? So I showed you how to undo addition, subtraction, multiplication, and division.